All right, so today's lab is about work and work energy theory. Specifically, it's about force times distance, okay? So what we're gonna do is we're gonna use an apparatus like what you see in the picture there. That is going to include a spring scale and a rubber band and 2 desks and at least 3 people, probably 4, okay? That's going to seem like a lot given what you're going to do. Okay? Here's the procedure of the lab. This rubber band is going to be put between the back legs of 2 desks. Okay, so you're going to pull 2 desks beside each other, take the little tennis balls off of the 2 legs that are closest, okay, and put this around the 2 legs. So when your experiment starts, it should just be taut. It shouldn't be stretched. Okay, just so that it's not sagging. Okay, everyone with me there? All right, then you're going to put a meter stick right underneath it. Okay, so you're going to put the meter stick down, and it's going to be right underneath the rubber band. Okay, so it's on the desk. The meter stick is going to be at the back. Okay, so the 0 will be at the back of the rubber band. Okay. Then you're going to hook the spring scale to both ends of the rubber band, and you're going to pull to a certain distance. Okay, now the distances I believe are already pre-selected for you in your lab report. Yeah, so the distances are already pre-selected for you in your lab report. So they are going to be 0.03 meters, 0.06 meters, 0.09 meters, okay, and 0.12 meters. Right, so 3, 6, 9, and 12 centimeters. Right, so you're just going to put the spring scale on there, and you're going to pull it until you get to those readings. Okay, now if you max out before you get to 12, that's okay. Just back it off and do 10 or something else, or pick a couple other ones that are in the middle, okay, in case it maxes out, because this rubber band feels pretty taut already at like 10, so okay, we may have to adjust the distances. All right, now here's what you have to do with this spring scale. Okay, first off, when you start, you have to make sure that the little metal tab is actually at 0, because this front sheet can move. Okay, and so like now it's saying that when there's nothing hanging on there, there's already 200 grams hanging on there, which is obviously not true. Okay, so you have to just make sure that it's at 0 perfectly before you start. All right, everyone with me on that? Okay, then you're going to put it on the floor. Okay, and you're just going to pull. Now, we need this to be in newtons because we're trying to do force and distance. Do grams measure force? They do not. So these scales, they suck. And there's not much we can do about that because we bought scales that are supposed to show grams and newtons as pictured on the box. What's in the box is not what's on the box. And Northwest Scientific wouldn't take them back. Hence, they've never got our business ever again because the customer's always right. If you ever have a business, remember that. We are right. These are not what we ordered, but we can make do. Okay? It's a very, very easy conversion. Whatever you have in grams, divide that number by 100, and that's what you'll have in newtons. I know, it's terribly inconvenient. Okay? We're probably all being little snowflakes complaining about it, but I'm going to complain about it. Okay? So, take whatever you got in grams, divide it by 100, and that will be your force in newtons. Okay? So that will get recorded in the chart. Okay? So we'll just record it here. Everybody with me so far? You good with that? Okay. All right. So that's all we have to do for the lab. Okay, like for the actual data gathering part of the lab, is we just have to set this up, put the rubber band in, and stretch it a couple of times, okay, and record the force. Then we'll talk about the analysis and all of that kind of stuff. Okay, so when you do this, you need to have at least, let's say, 4 people in a group. The job of 2 people is to be dead weight. They need to sit in the desks, okay? Because when I tried to do this lab on my own, every time I pulled on the rubber band, the desks moved, okay? Because I was, it was COVID, I was by myself in here. And so it didn't work very well. Actually, I had to fix it. But anyway, it won't work if the desks are not weighted down with people in them. So 2 people's job is just to sit there, okay, and to make sure the desks don't move. The other 2 people, 1 person to pull, and the other person to make sure that they are right over top of the ruler when they take the reading. Okay, so you can pull this to the 6 centimeters or whatever. That's the job of the person above, is to look and go, okay, that's exactly 6 centimeters, and because I'm standing right over top, I can see the face of the scale and do the readings. The reason I want you to be right over top is if you go to the side and look down, you'll bring an angle in there and you won't get an accurate reading. Okay, so 1 person to pull, 2 persons to weight down the desk, and 1 person to make the readings. Okay, all right. So put the desks, rear legs, take the tennis balls off, and this should go, just so you see the anatomy of the desk here, guys. Okay, when these come off, your rubber band should go in the gap between the feet and the shaft. Okay, so just put it right there, okay, that's where the rubber band should go on each desk. Yes, that's the most stable part, and it won't slide around in there. If you put it up here, it can slide up and down. Okay, these come off really easy, okay, but they also go back on really easy when you're all done. Okay, well, let's get the data, then we'll talk about the analysis. So for the analysis, you are going to have to build a graph. I forgot to put a Google Sheet in for your assignment, but it's easy for you to put it in. Okay, so if you go to the main assignment here where it says Work Lab, right? Just go to here where you see your Google Doc and it says turn in, it says Add or Create. Press Add or Create and put in a Google Sheet, and it will name it accordingly. It'll still say your name and Work Lab, and it'll make the Google Sheet. Okay, and then you can open that, and you'll have to put in the data. Now, the data needs to go in. First column is distance. Okay, the reason for that is distance is our manipulated variable. Spoiler alert, because I didn't go over the variables earlier, and I'm going to do it now. Okay, so that's going to be our manipulated variable, so it's going to go on the x-axis, and then obviously force is our responding variable, and it's going on the y-axis. You, by the way, still need to explain those 2 variables, okay, for the design part. Okay, controlled variables for your experiment. Remember how I was kind of particular about which legs of the desk you used and that the desks didn't move, things like that? Like basically anything that could affect the rubber band needs to be controlled, because if you do anything to that rubber band in the middle, it can change the properties of the rubber band. There may even be some environmental variables that could affect how stretchy the rubber band is. Okay, so make sure you identify how and why you were controlling those things, okay, when you're talking about your controlled variables. Okay, for your hypothesis, okay, so with your hypothesis, the if part needs to be a definition of work, okay? Okay, the and part, as always, is going to describe the experiment, okay, and then the then part needs to tell me how you're going to calculate the work done using this apparatus and this graph here that I'm about to go over, okay? So when you have got your graph built in Google Sheets, okay, get a best fit line on it, same as always, and it will look something like this. Okay? Question number 1 in the analysis wants you to calculate the area beneath the line on this graph. Now, we've done that with other graphs, like velocity versus time graphs, and on a velocity versus time graph, it represented the displacement. Is that what it represents on this graph? It is not, okay? Because when I calculate the area underneath this graph, I am multiplying what's on the x-axis by what's on the y-axis. And that calculates something important that we've done already. Okay, so just keep that in mind because you do need to do some explaining in question number 2. Okay, so I want the area calculated in question number 1. I want to see the calculations, want to see your work. Okay, and then in question number 2, I need an explanation as to what does that area represent. Part of that explanation needs to be the units you choose for this area. Okay, when you calculate this area, it is not meters squared. Okay, remember, you're not actually calculating area. Okay, that area represents something else, and that something else has particular units. Those units should go on that number when you calculate it. Okay. All right, then your conclusion, same as always. Okay, restate your hypothesis. Were you able to calculate work using the method you hypothesized? Okay, and then sources of error. Again, go back to your controlled variables. There are several sources of error within the controlled variables, mostly to do with the positions of the desks. Okay, and possibly the angle you might have been reading the ruler and spring scale at. Okay, those would be places I would look. All right, any questions? All right, you still got 20 minutes to work on that lab report, so let's make good use of our time.